Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.
Alrighty, let's take a look at our homework for 8.1.3. Our M&Ms are on compound interest. Hopefully you got all of this formula into your journal from the work that we did in class and watching the video. But when we are compound interest, it's a slightly different formula than simple interest because compound interest involves a situation where you have to take your principal and multiply it times a multiplier that is 100% of the principal plus the additional interest. And then that gets repeatedly multiplied a certain number of times for your new balance. Okay, so A, that represents the total amount that you're going to have after you complete this process with your calculator. Your principal, that's the amount that is either borrowed or deposited into an account, whether it's a savings account or whether it is a loan of some kind. Your interest rate, that always gets added to the 1. There's your interest rate for the compounding period, and the number of times. If you're using the variable n, I used t, it doesn't make any difference. The number of times that your particular account is being compounded. Okay, so it could be once a month for a year, which would be 12 months. It could be once a week for 2 years, which would be 2 times 52 or 104 times. You have to pay attention to the terms and specifically know how many times it is going to be compounded over a period of time. So the interest rate in this case is what? It is 1.5%. The principal in this situation is $1,425. And the amount of times it's going to be compounded is 12 times. So we're going to put all that into here. Here's the principal. Here is the interest rate. And remember, we're taking 100% of the principal plus the additional 1.5% to give us 1.015 for our multiplier. And then the number of times is 12. So if you want to take 1.015 times 1.015 times 1.015 times 1.015, and you keep doing that 12 times, then take that answer and multiply it times 1425. This is going to be your new amount. Or you can use your scientific calculator. So let's go ahead and do the scientific calculator where we take 1.015 and we raise it to the 12th power. That's going to be your multiplier, which this has been rounded off, and then keep this in your calculator and multiply that times your principal, 1425, and you get $1,703, and I think 76 cents is what mine rounded to. This must have been a round down. That's why the dollar amount is a little bit lower. If you want the exact answer, keep that decimal in its long form in the calculator and just turn around and multiply it times your principal, and you will get the correct answer, the most accurate answer, which is your new amount is going to be $1,703.73 or 75 cents, depending on how you rounded it, 76 cents. And then if you want to find out the amount of interest earned, then just take this amount and subtract away the principal, $1,425. And that's going to tell you that you earned $278.76 or 73 cents, depending on how you rounded it down here. All right, read this lesson's math notes we just did, and then answer the questions below. What does the 1 plus r in the formula represent? Why are the two quantities added together? Okay, so the 1, this 1 right here, represents 100% of the original amount. And the r, that is this part right here, represents the interest rate. So in a situation like this, the interest rate is 3%, so the quantity inside the parentheses would be 1.03. That means that the new amount is going to be 103% of the original, right? 100 is the original, 3 is the amount of growth or the interest rate, the amount is growing. Okay, so now it says Melanie is going to invest $2,500, that's her principal, at 3%, that's our interest rate, and it's compounded annually, means once per year for 4 years. So the formula, oh look, I included the scientific calculator there if we want to use it. I think maybe I will use that, if it even works. So A is equal to our principal. What was our principal again? $2,500 times 100% plus 3% is 103%, in decimal form is 1.03, and it is going to be compounded once per year for 4 years, so it's going to be compounded 4 times. Let's see what this scientific calculator gives us. Well, that didn't give me much of anything at all. That's not working. Okay. Oh, there it is. Okay. So let's clear everything. AC, clear. So what did we say was the dollar amount again? 2,500, 2,500, parentheses, 1.03, end parentheses, and now we're going to raise that to the 4th power. So I like the Google Scientific Calculator because it allows us to do everything and make sure we've got everything the way that we need it to be. Yes, that is correct. And when I hit the equals button, that's going to tell me the new amount. $2,813, and that would round to 77 cents, not 78 cents. There we go. Now, let's show it on this calculator. On this calculator, I am forced to do the exponent first. So 1.03 raised to the power of 4 gives me that as my multiplier. Then I multiply that times 2,500, and I get the exact same answer. So you could use different calculators. You just got to learn how each one of them operates so that you know that you're getting the correct answer. Every calculator is built a little differently, and so most of them have this this button right there if it's a scientific calculator. If it's a regular calculator, standard, you're not going to get that. All you can do with this standard calculator is square numbers. You can't take it to the 4th or the 12th power. So get yourself a scientific calculator or get used to Google's scientific calculator here. Okay, simplify each one of these exponential expressions. So 2 to the 4th power is 2 times 2 times 2 times 2. That's 16. Turns out 4 to the 2nd power is the same answer because 4 is 2 times 2. So this is also 2 times 2 times 2 times 2 if you were to expand it into its prime factors. 3 to the 6th power is 729, just as 9 to the 3rd power is 729. How does that work? 3 times 3 times 3 times 3 times 3 times 3. If I block these into groupings of 9, right? 3 times 3 is 9. You've got 1, 2, 3 nines there. 9 to the 3rd power is the same amount. 25 to the 3rd power is the same as 5 to the 6th power. Why? Because 5 times 5 times 5 times 5 times 5 times 5 is 15,625. You want me to prove it? I will prove it. 5 raised to the 6th power is 15,625. And so if we break this down to 25s, you've got 25 times 25 times 25 is 25 to the 3rd. It's going to be the exact same thing. 25 raised to the 3rd power, same amount. Okay, so what patterns do you see? The base of 1 is the square root of the other, right? This is the square root of 4. This is the square root of 9. This is the square root of 25. The exponent of the smaller base is twice the exponent of the bigger base. So squaring and taking square roots are opposites of each other, just like multiplying and dividing are opposites of each other. And we'll work more with that when we get into chapter 9 with Pythagorean theorem. All right, copy and complete the table at the right. We are going to get into exponent rules starting next in our next lesson, which is going to be most likely next week. Maybe it's tomorrow. I don't know how this is all working out as far as the calendar goes and whatever year this happens to be. If you're watching this in the year 2340, maybe tomorrow's lesson will be 8.2.1. But right now it's scheduled for next week. So 2 to the 3rd power in expanded form is 2 times 2 times 2, which is 8. 3 to the 3rd power in expanded form is 3 times 3 times 3. And you see the pattern there. Whatever the exponent is, that's how many times you repeatedly multiply. And then standard form is the way we would normally write the numbers. So 5 to the third is 125. 6 to the third is 216. 7 to the third is 343, and so on and so forth. So here you see the patterns for the factored form, but I'm not sure if there's any real pattern here other than you just got to do the multiplication. All right, let's see about this problem. It's a word problem, so we would follow the 5D process. Jen, Carrie, and Fran are each thinking of a number. When you add their numbers together, you get 207. So that's going to be the total sum, right? 207. What else do they say? Jen's number is 9 more than Carrie's. And Fran's number, there's Carrie right there. And then Fran's number is 3 less than Jen. Okay. So if I make Jen's number J, then Fran is going to be 3 less than Jen. So that would be Fran right there, right? And then Carrie, Jen's is 9 more than Carrie, which makes Carrie 9 less than Jen. So that can be a little bit confusing here. So a lot of times, I'm just going to remind you of this process. Sometimes I just make up numbers, okay? So if we just said Jen was 30, I would have to make Jen's numbers 9 more than 39, so she would have to be 21 because Jen, her number is 9 more than Carrie's, right? So that would be Jen's minus 21, or if we made Carrie our variable, then this one would have to be whatever Carrie's variable is plus 9. But I decided to do it in this order. So this is J minus 9. And then Fran's number is 3 less than Jen's. So hers would have to be 27. And when you add those together, they're supposed to equal 207. So no, this is way too low. Now, we're not going to do the guess and check table. We're going to solve it algebraically. So I'm going to take, here is Jen's number. Here is Carrie's number, and here is Fran's number. And when you combine like terms, the 3 J's are there, and then -9 and -3 make -12. So we will now go ahead and add 12 to each side, then divide by 3, and that's going to tell you what Jen's number is. So once we know that Jen is 73, we know that this is going to be 73 minus 9, which would be what, 64? Yeah, 64 plus 9 is 73. And we'll know that this one would have to be 70 because that's 3 less than Jen's number. So why am I adding all these together? Because I have to decide. Remember, with the guess and check table, the decide was worked into the process. But when you solve algebraically, you've got to make sure that all of these numbers agree with our definitions and with the total, which is 207. So 3 and 4 make 7. 14 and 6 makes 20, so that's 207. That is correct. So we can declare our answer. Jen's number is 73. Oh, we weren't declaring Jen's number. We're declaring Fran's number. Fran was 70. There you go. Fran's number is 3 less than that, so that would be 70. All right, rotate this 90 degrees. I don't want to do this problem, people. I don't want to show it. It's hard to do, but at least you're doing it around the origin. So remember, every one of the corresponding points is going to form a right angle. And so if this goes down 2 and 1 to the right, then you know it's going to be a change of 2 and 1. So 2 and 1 gets us here. Does that look like it forms a right angle? Yes, it does. So this is the new point B. We do the same thing here. For A, we think it's going to form a right angle. So this goes 2 and what is that? 1, 2, 3, 4, 5. So we're going to go 2 and 5. Does this look like it forms a right angle for 90 degrees? Yes, it does. So that's the image of A. And then C does the same thing. It goes, this is going to be a lot easier. A right angle, boom. 5 units to get there, 5 units to get there. So this red triangle is the 90-degree rotation clockwise about the origin. All right, compound interest problem. Daniel has $1,200 in the bank. He's earning 3.5%, and it's compounded how much? Each month. So how much money? Actually, hold on for a second. Let me color coordinate a little bit here. We got our principal, which is our principal, which is our principal. We've got our interest rate, which is our interest rate, which we're going to put there in decimal form and add those together. And then our time is 1 year, but it's compounded each month. So that's going to have to be 12 times that it gets compounded. So we are going to write this out as A is equal to 1,200 times 1.035, right? This in decimal form, 3.5% would be, move that decimal 2 places to the left, get it into decimal form, 0.035. And then raise it to the power of 12. So do you want to use Google Calendar or Google? Yes, let's use Google. So we got 1,200 times 1.035 in parentheses and raise that to the power of 12. Let me make sure that's what I've got written down. 12, yes, that is right. We hit equals and you get $1,813.28. It does not round up to 29 cents. So there is your answer. And is this an example of linear or nonlinear? It's exponential growth. So that is non-linear. There we are. We are done. How much time did that take? Not too bad. All right, let's move on. I have a feeling you might have an assessment coming up. If not, there's something going on. So take care. Bye.
Hey, feeling good, like I should. When in dark, walk